Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 101 in our incredible new tutorial series where you are unleashing the power of your Raspberry Pi Pico W. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the Kepler kit for Raspberry Pi Pico W. Now, hopefully most of you guys already have your gear, but if you don't, look down in the description. There is a link over to Amazon. You can hop on over there and pick your kit up. And believe me, your life and my life are going to be a whole lot easier if we are working on identical hardware. But enough of this shameless self-promotion. Let's jump in and talk about what I am going to show you today. Now, what we did last week is we saw how we could control two servos using two different state machines on the Raspberry Pi Pico PIO state machines. Okay, so we showed how we could control two servos. But it was very cumbersome. If you wanted to add a third servo, you would have to change the code. If you wanted to change other things, you would have to change the code. So what we wanted is we wanted to move that program that was working and reconfigure it where the state machine work and all the servo work was being done in a Micropython class. Now, class is something that I've taught several times, but it's something that you've got to see a number of times. It can be a little bit daunting at first, so this should reinforce learning that we've had earlier in this class and in other class. And really, if you really want to get the most bang for your buck in your programming, you want to become more comfortable with Micropython classes. I should ask, how many of you were successful? If you were successful, leave a comment down below. I am legend, double chest bump. And if you were not successful, leave a comment down below. I fold it up like a cheap Walmart lawn chair. Okay. Well, don't worry, because if you're not comfortable with classes, it's one of those things that takes a few times in order for you to become familiar with it. And so let me get out of your way. I'm sorry, we don't seem to have any boats today. Maybe some boats will show up before this is over. But let's jump in and let's see if we can go ahead and get ready to code. Now, the first thing I do is, because this is getting to be kind of more complicated stuff, I don't want to start completely from scratch. I want to start where we left off last week, where we had a functioning program. So I will need you to go to the most excellent www.toptechboy.com. And once you're there, I want you to search on something like using multiple Raspberry Pi Pico state machines at the same time. You come down here, you look for these two happy little page icons, you click on it, and now you have copied last week's code. Now we come over here with a fresh new Thonny window and we paste it. Now we always like to see if the world is in proper working order, so let's run this and make sure that this code from last week still controls two servos. So we will hold our breath. And boom, okay? And you can see they're being controlled independently because they are going in opposite directions. Okay. Sorry, I got to clear my throat. I'm getting over a little bit of one of those viral chest infections, but everything's okay. And I will forge on. All right. So now we're going to come over here to the code, and you can see that we have that all in there. Let's just look at it a little bit. This is our text decorator that defines our servo control software, the machine language in the state machine servo control code. And mainly what this does is it has the timing loop that creates the perfect pulse width and the perfect period so that the servos go where we want them to go. Now, what we showed last week is that we could instantiate state machine 0, and it could use this code. And then we could instantiate state machine 1, and we could, we could send it to that same function. Okay, and so state machine 0 and state machine 1 can use that same function, can use that same 32 lines of memory, or whatever this was. I don't know. This was like 12 lines of code, and those two state machines are sharing the same code, so that we're not just chewing up our very precious 32 lines of code. Now, I might have said things a little bit confusing last week, so I want to say it again very clearly. State machines 0, 1, 2, 3 are on one PIO block. Those 4 state machines share a total of 32 lines of code. So if we used all 4 state machines, each one could only have 8 lines of code if each program is independent. But what we do here is these two use the same function. So these two only require the 8 lines of code, because those 8 lines of code are being shared between 2 state machines. Now, what I also showed is last week that we can instantiate a second state machine, like this was state machine 0, and this is state machine 1, and state machine 1 and state machine 0 are on the same PIO block. That PIO block has a total of 32 lines of code, and with these two state machines running, we've only consumed this many lines of code, because it's not like state machine 0 is using this block and state machine 1 is using this block. No, they're both using those same lines of code, and they can do that without interfering with each other. Now, I misspoke last week, and I said that if we went to like state machine 4, which is on the second PIO block, it could go up and use those same memory locations. I misspoke, or I left the wrong impression when I said that what we do here is, with this instantiation, it downloads this code, the compiled version of this code, into the 32 lines that we have in PIO 0, or the first PIO, which is state machine 0, 1, 2, 3. Now, if I move this second state machine to state machine 4, which is on the second PIO block, now I've got this 8 or 10 lines of code once on PIO 0 and again on PIO 1. And so the function is shared, but it is stored on both PIO blocks. So state machines in PIO block 2 cannot use code in PIO block 1, but you can share a function, but this function is compiled once and sent to PIO 0, compiled a second time and sent to PIO 1. But now that's different. That would be if I had state machine 0 and then state machine 4. You end up with a copy of the code on PIO 0 and PIO 1. But if I leave this as 1, that is only compiled once and is only one block of code in the PIO 0. So if that doesn't make sense, go back and listen to it again, because it's kind of an important thing to understand as we start doing more complicated stuff. Okay, now what was your assignment? All of this stuff that is the heavy lifting here, all of this heavy lifting we want to put in a class. Also, down here in the while loop, where a user might be writing a program, we don't want to be talking about SM0 puts and executes and pulls and all of that. We want down here for the casual programmer to just interact with the servo through an object that is created by a class. So we want to hide all of this ugliness, okay? And we want to hide all of this ugliness inside of a class, okay? So let's jump in and see if we can do that. Let me get that out of your way so that you'll see everything that I'm doing. You know, guys, when I sometimes need to clear my throat or cough during a video, I get a lot of angry emails. Why don't you go take some cough syrup? Is there something I can take? I would, but it's just like, you know, you get a little viral infection or whatever, a little respiratory infection, and I could sit here for 2 weeks and not do any work, or I could just power on through. So I appreciate that you guys are patient and not get upset with me that, yes, real human being, yes, I do cough sometime. Okay, so what do we want to do? All of this stuff here, I am just going to come here and I am going to create a class. And I'm going to call that class servo state. Okay, servo state. Now I want all of this code up to, I want all of this code. How much code do I want? I got to kind of think through this. What I want is, I want all of this code inside that class. Okay, I want all of this code inside that class. And in fact, where I give the text decorator, that needs to go in the class as well. So what I'm going to do is I am going to indent that. So I'll come in and say indent. And now all of this is scooted over. All of this is scooted over, and it is now part it is now part of this class servo state. All right, now what do I want to do? I want to do all of this type of nonsense inside of the class, because that way, if I do it inside the class, if I want to create a servo, I just say my servo is equal to servo state the class, and I pass it the pin number. So all of this stuff that a typical Python programmer would not understand, it needs to go up in the class, if that makes sense. Well, here I am instantiating a state machine, and then I am initializing it. Then I am doing another instantiation, and I am doing another initializing. Okay, so what do? I need to do that up here, and I would do that when I create the object. So what is executed when you create a Micropython class object? What is executed is the init. Def underscore underscore init underscore underscore, and then I pass it self, and self is whatever object you're creating. So if I created an object servo1, for that instance, self becomes servo1. If I create an object servo2, self becomes servo2. So self allows each bit of code to keep track of who it is. Then what else do I need to pass it? I need to pass it the servo pin, like that. Okay. Now, what do I want to do in here? What do I want to do in here? I want to instantiate the machine. I want to instantiate the machine. So it's going to look something a whole lot like this line, okay? But I'm going to come up here and I'm going to put this line inside of the init, like that. But you see down here when I do it, I'm physically naming it state machine 0. But I want the init to automatically name it based on the object that I create when I call the class. So instead of saying this is SM0 up here, it should be self. So if the object is servo1, it'll become servo1. If the object is servo2, it will become servo2. But it will be self dot what? Self dot SM, because I have to give it some method name here, so I'll just call it SM. So self.sm, and then that's going to be equal to all of this neat stuff. Now, what's one thing that you see? Do I want to put a 20 here? No, I don't. What do I want to put there? The pin number that was passed to it. So I'm sort of like making this generic. I'm taking specific code and I'm genericifying it, if that makes sense. Okay, that's probably not a word, but let's say servo pin, like that. So now, what would I do? What would I do? Down here, instead of doing this, what would I do? I would create an object, my servo 1. What is that object? It's equal to servo state, the class, and then what pin I'm using, 20. So it sees servo state, it runs up to here, and then it comes down and it runs the init where it makes this self becomes what? For that instance, it becomes my servo 1. So this, you could think of it as my servo 1.state machine is equal to this. Now, if I did another one, like if I did another one down here, and I said my servo 2 is equal to servo state and maybe at pin 21, what is the problem? It would try to put that on state machine 0. What's the problem? State machine 0 has already been used. So every time I create an object, I need to put a counter here. And every time I create an object, I need to increment that counter. Now, what you could think about is up here, I can go ahead and create the counter. So I'll say counter equals 0 because I want to start with state machine 0. And remember, this is servo state is the class and counter is the variable. And so what would I put here? I wouldn't put a 0 and I wouldn't just put counter because this init doesn't know what counter is. So I've got to tell it it is the kind of class variable, which would be servo state dot counter. Servo state dot counter. Now, what I better do before I forget it, I got to remember after I'm done initializing this first state machine and this first servo, after I'm done initializing that, what do I need to do with the counter? I need to increment it. Servo state dot counter is going to be equal to servo state dot counter plus 1. So I create state machine 0, and next time through, this has been incremented. So next time through, I would create on state machine 1. Okay, hopefully that makes sense. Now, the only thing that's a little bit confusing is when you're right up here in the top of the class, you just define the variable. But when you come down here in these functions, you've got to tell it that it is the class servo state class and the variable counter. Okay, so hopefully that makes sense. Now, what else do I want to? I want to activate it. So I'm going to say self.statemachine.active and make that a 1. Okay, so I make it active. Then what else do I want to do? I want to do all of this other stuff where I pass it the period of 20,000 microseconds. I initiate a smo.exec Python command, which will then execute this line of machine code in that state machine. So, excuse me, so I want to do all of this stuff here as well. So I'm going to cut that so I'll remember that's taken care of. And then that is going to come here. Okay. And that was a big old ugly mess. So I'll tab those over. Okay. But it's not going to be SM0 self. That would have been a disaster, wouldn't it have? Okay. It's not going to be an SM0. It is self. Okay. It's going to be a what? It's going to be a self. Man, I can't type today. It is going to be a self.state machine. I am really confused about what has just happened. Oh, I see what I did. I probably copied and pasted that even though I'd already put it in. Okay, so this then, instead of state machine 0, which is a specific name, I will give it based on the object you created, dot state machine. Okay, and instead of state machine 0, it's going to be self.state machine. And then this is going to be self.state machine. And if you guys are expert, I'm sorry that I'm explaining this in great detail, but let's think about it. Now when I create my servo 1, what is the state machine going to be called? It's going to be called my servo1.sm. If I then create my servo 2, then self for that object is going to be servo2.sm. Okay, and so this just allows us to have one set of code that will work with a lot of different components. Okay, so now we have incremented our counter. So anytime I call servo state, it will initialize a new state machine to control a servo based on the object name that I give it here. Okay, I hope I am not confusing you by going too fast. I hope I'm not boring you by going too slow. Okay. And now what I'm going to do is I'm just going to give myself a little note here. And what I'm going to do is I'm going to print state machine, and then I'm going to concatenate that with the string value of servo state dot counter. Okay, and then I'm going to close that. And now I'm going to concatenate that with the word space created. So as I create these state machines, I can see that they're created with this little print line inside of the init, and that'll help us debug things if we got a problem. And it seems not to like that. I didn't put an ending quote there. And I should probably keep this consistent and use double quotes. So I'm thinking at this point, I have created and instantiated a state machine that will control a servo. And every time I call it, it'll create servo 0, servo 1, servo 2, servo 3, servo 4, because this variable is being incremented every time through. Okay, now, at this point, it would almost work. At this point, it would almost work. I can get rid of all this because I don't have to do each one individually down here. I don't have to do each one individually down here. If I want a second one, I'll just say my servo 2 is equal to servo state, and then I pass it a pin. I've got one of my servos connected to pin 20, and I've got the other one connected to pin 21. So we can go ahead and create those. So now you see all of this in the class is hiding all that more complicated code, and we can make this easier. But what's wrong here? I'm doing SM this put, SM this exec, and you could imagine that I could give it like my servo 1, and then I could put it a dot put or something like that. But I really don't want that. I don't want the user to have to think about any of this. All I want the user to have to do, is say my servo, all I want the user to have to do is say for angle in range 0 to 180, and then I want to just do my servo 1, which I created, dot servo angle, and then pass it the angle. I pass it the angle. I create the angle here. Now I pass my angle to the servo angle method up here. What's the problem? I haven't defined that method yet. So what are we going to do? We're going to come up here and we're going to define it. So I'm going to define servo angle, and what do I pass it? Self, so it knows, am I talking to servo 1 or am I talking to servo 2? So I've got to pass it the self, and then I'm going to receive what? The angle. Okay? So I'm going to receive who you are and what angle you want. Now the code should be almost identical to these 3 lines. I think these 3 lines. So I'm going to cut those 3 lines, and then I'm going to come up here and I am going to put those 3 lines here. So I calculate the pulse width with this equation. No, this equation only works for like servos like the SG90 that look for a pulse width between 500 and 2500 microseconds. You would have to change this equation if you were using a different servo with a different desired, timing sequence. All right. Now, when I say SM0.put, he doesn't know who SM0 is. He knows who self is. And then remember, we put that SM in there. And then this becomes what? SM. It becomes self.sm. Okay. So if I say my servo 1.servo angle, it comes up to servo angle. And then what is self? Self becomes my servo 1. And because of what we did up here, he will know that he needs to talk to pin 20. Okay. So that's as simple as that. Now this down here, this gets a whole lot easier now. And I'm going to take these 2 lines of code out because this was for the second servo. And so I'm just going to go here. I'm going to say what? My servo 2.servo angle. I want to show that I can control them independently. And so instead of moving it to angle, I'll move it to 180 minus angle. And that way they should be going like this. All right. What am I forgetting here? Could it really be 2 lines of code? Okay. And I'm going to take this second for loop out for right now. Okay, and then I'll just make a sweep, wait. It'll pop back and make another sweep. So let's see if this works. Let's see how many horrible mistakes I made in here. Servo set isn't defined. What is that? My servo 1, my servo 2. Servo set in line 19. A servo set. What else did we forget? Which servo set do you want? You have to tell it which servo set you want. And that is stuff that's up here at the top of the class. So I've got to, just like I had to tell it this is a class variable with servo state dot, when I'm going to do servo set, I've got to do the same thing. So I have to do servo state dot, just like I had to do servo state dot here. If I want to access stuff up here, I got to tell it it's up in that class so it knows where it is. So servo state dot servo set. All right, now let's see what else we got going here. I might have forgotten something like that somewhere else. Boom! I should have had this over here to our cool view. Let's look at that. All right, what do we have? I'm controlling two servos. Okay, I'm controlling two servos, waiting 5 seconds, and then they pop back, and then they go again. So it's doing exactly what I wanted it to. But let's come back over here now and let's look at this code. All of this heavy lifting is done inside of the class. All the user has to do is think in terms of simple Python. Well, I want servo1. So what will I do? I will create the object myServo1, which is of the class servo state, and it has been passed its pin number 20. Okay, its pin number 20 will be passed in, and then the init will get that 20. The init will get that 20, and then, let me get out of your way, and then when it sets the base pin over here, the 20 comes here. So where does the 20 go? The 20 goes from here, and then it goes into servo pin, and then it goes here, and then it goes here, then it goes here into the instantiation. Okay, because it was passed here, 20 goes into servo pin, and then servo pin goes here. Next time, when I create the new servo, which is going to be 21, 21 is going to be passed into the init. This will be 21, and then for that new object, man, I just can't be careful. Okay, then that new object, that new servo object is going to know that it is at pin 21. Does that make sense? Okay, let's just do a little bit of cleanup here. I'm going to take this and I'm going to copy it because I hate swinging back 180 degrees at a time. So what I'm going to do is I am going to create a second for loop, but this time I am going to go from 180 to 0 in steps of -1. And this time I will, in fact, be moving smoothly in both directions. So let me go ahead and run this. Okay, running without errors, and look at that. We have them moving in opposite directions. Okay, and if you look at this, I've got the scope on both of the pulse width. This, guys, I've mentioned this before. I have the link to this oscilloscope down below. And as you start working with state machines, they're very hard to debug because you can't do a print statement in the middle of the state machine code. So you need to be able to look at the signals that you're generating. And what you can see here is yellow, which is this one is a minimum when blue is at a maximum. So let's wait, it'll be opposite this time. Blue, this one is going to be at a minimum, which is 0. This is at a maximum, which is 180. And you can look at these pulse widths and you can make sure that your state machine is generating exactly what you want. And if you're going to get serious about this and you're going to try to write some more complicated code, you really need to be able to look at your signals, if that makes sense. Okay, guys, I hope you follow along with me, and I hope that you are not finding this tedious, but I just want to emphasize now, all of our hard work is done in the class. Anybody who wants to use this, all they need to do is create a servo object, tell it what pin it's at, and then come down here, and all they've got to do is their object, my servo1.servo angle, and set it to angle. Now let me also show you something. Let's just say, could I do more? I don't have 8 servos handy, but let me see. That's 4. That's 6. That's 8. And so let's call this servo 1, servo 2, servo 3, servo 4, servo 5, servo 6, 1, 2, 3, 4, 5, 6, okay, 7, and I started counting at 1, so this would indeed be 8. And I could say this is pin 21, pin 22, pin 23, pin 24, pin 25, pin 26, and pin 27. Now, know that when I do state machines 1 through 4, they are all going to be using that same memory block in PIO, the first PIO, PIO 0. It's going to be using that same memory block in PIO 0, which is going to have the compiled version of this code. But now when I use my servos 5 through 8, that time when you end up with a 5 here, then it is going to send a 5, a 6, a 7, or I guess it's 4, 5, 6 because we started counting with 0, 4, 5, 6, 7. That will send this code to the second PIO block. So let's count exactly. We've got like 1, 2, 3, and we've got 4, 5, 6. We've got 6 lines of code. That 6 lines of code is going to be compiled and put in PIO 0, and then it's going to be compiled and put into PIO 1. So we're going to have consumed 12 lines of code, and we've got 32 and 32. If we made 8 servos, we would have used 6 out of 32 lines of code in PIO 0, and in PIO 1 we would have used 6 out of 32 lines of code, and so we would have used 12 out of 64. But right now, because the second one that we're actually running is going to be state machine 1, it could share that code with the earlier one. But when we get down to state machine 5 here, because it'll go 1, 2, 3, 4, when I get to my servo 5, then that is going to have to put another little thing of code in the memory for PIO 1. All right. And then these next 4 ones could share it. But let's just see if I could create 8 different servos. All right. So we do that. And look at that. State machine 0, 1, 2, 3, 4, 5, 6, 7 have all been created, and the 2 that I have a servo connected to are running. Now, I really shouldn't do stuff like this live, but I'm going to move this one servo to pin 22, if I can. I'm going to move it to pin 22. And now I would be using what? My servo 3. So there, I would need to come in and change this to my servo 3 and my servo 3. And let's run it. Okay. Yeah, that didn't work. Did I not get that in there? I told you I shouldn't be doing. Oh, okay. I see what I need to do. I didn't move that. Let's try it again. Still didn't. So I went from 20. I told you I shouldn't do this on the fly. My servo 3 is on pin 22. That sure looks like it's on pin 22. What did I do wrong? My servo 3? My servo 3 is on pin 22. See, the hard thing is I can't see this absolutely perfectly. It sure looks like I got that on pin 22. What did I do wrong? My servo 3. It's not ending up in there. Oh. Let's see if we can go back to, let's go back to where it was and see if we can make it work. Okay, so I put it back there. I really shouldn't do this live. I did this the other day and I know it works, but I'm not sure what I am doing wrong. So my servo state 2 is on pin 21. And so I'm going to come back down here and say servo pin, so my servo 2, my servo 2. So that works. Let me make sure that 22, let me make sure that that's a GPIO pin that I went to. 18, you know what? That next pin is a ground there. That is a ground. So I just thought that 21 would come after 22. So that is the ground. And now I am officially on GPIO pin 22. So we'll come back here and we'll make this servo 3 and servo 3, and servo 3 is connected to GPIO pin 22, and boom. Do you see that? And now the one other one that I really want to try is, I want to come down to servo, my servo 5. And why do I want to go to my servo 5? Because I want to make sure that this works using both PIO blocks. So I'm going to change this to my servo 5, which should be on the second PIO block. Like that. Okay. Now let's come up here and say my servo 5 is GPIO pin 25. And I don't want to mess up again. So that's 22. I skip one. Where's GPIO pin 25? I am going crazy because I'm not seeing a GPIO pin 25. It goes from 22 to 26. Nevertheless, let's move it to 26. So that's... Okay, I think that's 26. So this is 21, skip 1, skip 1, 22. Give me a second, guys. I need to go over. I'm trying to get to what? To pin 25, 26. So from where I am here, this is, believe me, this is more painful for me than it is for you. Okay, so I'm looking here. So that is going to be pin 20 and then pin 21. And then I skip the ground. And then this is pin 22. And then I skip the run. And now this is GPIO pin 26. So my servo pin 7 is on GPIO pin 26. So let's see if we can do that. I just want to make sure that I can run I can run on both of the state machines. You know, one on one and one on the other. All right, boom. So we have it. This one is working on PIO 0 on state machine 0. This is running on PIO 1 on state machine 6, right? We went to state machine 6, which is my servo 7. Now, why is that? I'm labeling my servos counting from 1, and the state machines are labeled counting at 0. So my servo 1 really runs on state machine 0, if that makes sense. Okay, guys, do you hate me now? Do you really hate me? I mean, hopefully this wasn't too tedious. But I want you guys to start getting familiar and comfortable using the Micropython class capability. And I hope you see here the reason for it. I hope you see that it allows you to put the difficult stuff in a class so people can interact with it on something that is very simple and Python-ish and not something that requires a very high level. Okay, we should do the homework now. Okay, and what the homework is, I want you guys now to create a library. Okay, I want you to create a library so that now your code is going to look, let me see if I can find it. Your code is going to look like this. You are going to create a servo library. And all you're going to do is import that library. Then you're going to create your servo object 1, and then you are going to create your servo object 2. Okay, and if I remember this was pin 26, I think I can just change it here. Okay, like that. And now when I run it, okay, look at that. All right. Now for your users, is there anything in here complicated? No. What am I trying to run? A servo. What does it need to know? The pin number. What do? I set an angle with my object dot set angle. The what? The angle. So what I want you to do, your homework for next week is to create a library that you just have to import, and then you can make your program super simple. All right, guys, I hope you guys don't hate me for the coughing, and I hope you guys don't hate me for trying to encourage you to get more familiar with classes. And now I'm going to have you take it to the next step where you're going to create a library. Now you're kind of getting into the big leagues because you're creating libraries that work with real physical objects, and you're making it accessible to people who are only comfortable with your kind of normal Python commands. Okay, guys, I hope you enjoy taking this class as much as I do making it. As always, I want to give a shout out to you Patreons who are standing with me on really in-depth, advanced lessons like this. I don't get 100,000 viewers. I maybe get 1,000 or 2,000 or 3,000. The only way that I can continue to make these more in-depth lessons is by having you guys support the work on Patreon. So thank you. You can also help me by giving me a thumbs up. Okay. You can also help by leaving a comment down below. Subscribe to the channel if you haven't already. When you do, make sure you ring that bell so you'll get notifications when future lessons drop. And most importantly, share the video with other people, because the world needs more people working on state machines and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.